Here is a Bernoulli equation, and we know a Bernoulli equation is of the form dy over dx plus some function p of x times y equals sum of the function f of x multiplied by y raised n. So I'm going to divide this function by x on this equation by x on both sides. And if I rewrite it, I'll see that p of x is equal to 1 over x, and f of x is equal to 1 over x. So since this is Bernoulli, we could simply use the substitution. U equals y raised 1 minus n, and n in this case is negative 2. So we would have y raised 1 minus 2, we get y cubed, which would mean du over dx is equal to 3y squared times dy over dx. Do not forget to do implicit differentiation. Here y is a function of x, so we are differentiating y cubed, so implicitly you have to multiply it by dy over dx. So that is what we have, and I am going to rewrite dy over dx as 1 over 3y squared du over dx. I'm going to go back and replace the original dE with what I have. So which is dy over dx plus 1 over x times y equals 1 over x times y raised minus 2. I'm going to replace dy over dx by the substitution 3y squared times du over dx plus 1 over x times y equals 1 over x times y raised negative 2. Multiply both sides by 3y squared. So we will have du over dx plus 1 over x, 3y squared times y, 1 over x times 3y squared times y raised negative 2. Those two would go away, and we will have du over dx plus 1 over x multiplied by 3y cubed equals 3 over x. But we know that u is y cubed, so I could rewrite it as du over dx plus 1 over x, 3u equals 3 over x. Which would imply du over dx is equal to 3 over x minus 3u over x. We have a 3 in common, or 3 over x in common, so we have 1 minus u. So we'd end up having du over dx equals 3 over x times 1 minus u, which would mean du over 1 minus u equals 3 times dx over x. So if we integrate on both sides, that is a separable equation. So if I integrate on both sides, I would end up getting negative ln of 1 minus u equals 3 times ln of x plus c. Now what did I do here? I simply used the substitution. T equals 1 minus u, du is negative dt. The integral would become negative dt over t, which would result in what I have on this side. Now, I could move the negative 1 inside, which should give me 1 over 1 minus u equals ln of x cubed plus c. I can exponentiate on both sides. Would I have a negative? If I exponentiate on both sides, I have e raised ln of 1 over 1 minus u equals e raised x cubed plus c. The e and the ln, it's e raised ln of x cubed plus c, which I could write it as e raised ln of x cubed times e raised c. Those two would go away. I'd simply have 1 over 1 minus u equals x cubed. E raised c is another constant, so I'm just going to call it as c1. And 1 over, keep in mind, u in our original substitution was y cubed. So I have 1 minus y cubed equals x cubed times c1. 1 minus y cubed would then equal to x raised negative 3 times 1 over c1. But 1 over c1 is yet another constant, so I could write it as c2. So 1 minus y cubed is equal to x minus 3 times c2, which should imply 1 minus x raised minus 3 c2 to be equal to y cubed. And negative c2 is yet another constant, so I could simply write it as positive. So I could write it as c3 x raised negative 3 equals y cubed. So that would be the final simplified answer. Now, key thing to notice here is anytime we start with the Bernoulli equation and make the substitution, at the end of the day, it must reduce to a separable equation or a linear equation. So in this problem, it reduced to a separable equation. In the next one, it is going to reduce to a linear equation. And not only that, this problem is a initial value problem. So I'm going to divide the equation by x squared on both sides. So I'd have dy over dx minus 2x over x squared times y equals 3 over x squared times y raised 4, dy over dx plus negative 2 over x times y equals 3 over x squared times y raised 4. That looks like a Bernoulli equation. We have p of x equals negative 2 over x, f of x is 3 over x squared, and n is 4. So our substitution should be u equals y raised 1 minus n. In this case, y raised 1 minus 3. Oops. 1 minus 4, which is y raised negative 3. Take the derivative, du over dx would equal to negative 3, y raised negative 4. Do not forget implicit differentiation, dy over dx. dy over dx would then equal to 1 over negative 3, y raised negative 4, du over dx. I'm going to move the y raised negative 4 in the denominator to the numerator. And I'll get y raised 4 over negative 3. Going to replace the original dE, that is over here, with my substitution that I nicely came up with. Y raised 4 over negative 3 du over dx minus 2 over x times y, 3 over x squared times y raised 4. Divide by y raised 4 on both sides. Have minus 1 over 3 du over dx minus 2 over x, y over y raised 4 equals 3 over x squared, y raised 4 over y raised 4. Then I'd have 1 over 3, negative 1 over 3 du over dx minus 2x times 1 over y cubed equals 3 over x squared. But 1 over y cubed is simply y raised negative 3. But what is y raised negative 3? That is simply u. That was our substitution. So, which we have here. Negative 1 over 3 du over dx, negative 2 over x, u equals 3 over x squared. Multiply by negative 3 on both sides, you'd get du over dx plus 6 over x times u minus 9 over x squared. Now that is a first order linear equation, and that looks like u prime plus p times u equals g of x. It's a first order linear dE. And we know how to solve that. The first step is to find the integrating factor. Which is simply mu e raised integral p times dx. So e raised integral 6 over x dx. E raised 6 times integral dx over x e raised 6 integral dx over x is ln of x, which is e raised ln of x raised 6. E and ln would go away. We have x raised 6. So the integrating factor is x raised 6. So the solution is, keep in mind the dE here is in terms of u, so the solution is u equals 1 over mu integral mu times g of x dx plus c. So 1 over x raised 6 multiplied by x raised 6. G of x is negative 9 over x squared dx plus c. 1 over x raised 6 integral negative 9 times x raised 4 dx plus c. So that would equal to 1 over x raised 6 negative 9 x raised 5 over 5 plus c. Distribute the 1 over x raised 6 inside. We'll have negative 9 times 5x plus c over x raised 6. And that is equal to u. But what is u? According to our substitution, u is y raised negative 3. And that is our solution. But since this is an initial value problem, when x is 1, we have y to be 1/2. So we are going to plug in 1/2 raised negative 3 equals negative 9 over 5 plus c. 1 over 2 raised negative 3 is 8. Move that negative 9 over 5 to the other side, it becomes positive 9 over 5, which would imply the constant is 49 over 5. Therefore, the solution is y raised negative 3 equals negative 9 over 5x plus 49 over 5x raised 6. So things to keep in mind: if everything works well, a Bernoulli dE will reduce to a first order linear equation that can be solved using the regular first order linear equation approach or using separability. So here is a case where we solve using substitution, and in this case the substitution would result in separability. So we have a function of ax plus by plus c, which is right here. So I am going to use my substitution u as y minus 2x plus 3, which would imply du over dx is dy over dx minus 2, which would mean du over dx plus 2 is equal to dy over dx. Now I could rewrite the original equation. So the original equation is y prime equals 2 plus square root of y minus 2x plus 3. Y prime is dy over dx, which I have to be equal to du over dx plus 2 equals 2 plus square root of u. The 2's go away. I have du over dx equals square root of u, which should imply du over square root of u, which is equal to dx. So that is separability. So because of the substitution, we were able to achieve separability. Now all we have to do is integrate on both sides. So integral 1 over u raised 1 over 2 du equals integral dx, which is integral u raised negative 1 over 2 du is equal to integral dx. When we integrate, we have u raised 1 over 2 over 1 over 2 equals x plus c. That would mean 2 u raised 1 over 2 equals x plus c. And 2 square root of y minus 2x plus 3 equals x plus c. I'm putting the substitution back. And if you don't like the square root, this is the same. If I square on both sides, I have 2 times the square root of y minus 2x plus 3 squared equals x plus c squared. So 4y minus 2x plus 3 would equal to x plus c squared. So you may leave the solution as is here, or you can write it that way. It is a matter of preference, so either would work.